Here's a mini lesson on adding and subtracting with scientific notation. The key here to remember is that, as you see in the first question, we can only add and subtract when the powers and the bases of the power are the same. This is important because it's much like place value. So if you really think about these two numbers carefully, it's simply, if we look at 3.2 times 10 to the power of 4, the number is really 32,000. 1.8 times 10 to the power of 4 is really 18,000. That's moving the decimal place 4 times. Hopefully you'll notice that because we have the same base and power, you can see that it makes these two really easy to subtract, because the place value columns align. 32,000 take away 18,000. Same base, really easy in this case to then subtract. If they weren't to say, for example, as 10 to the power of 4 and the other one was 10 to the power of -3, you can see how these numbers are vastly different. One a really big number, one a really small number, and the place value columns would not align for us to add or subtract. So in this case, you can see that the answer should end up at 14,000, or 1.4 times 10 to the power of 4. Let's see. 3.2 take away 1.8 is equal to 1.4, and then the power and the base stay the same, so 10 to the power of 4. Let's apply the same to the second question. You'll see that we have an addition equation and the base and the power are the same. So we can go ahead and this time add. So it's going to be 6.2 plus 2.35. That answer will give us 8.55. And the base and the power, stays the exact same. So times by 10 to the power of -3. And that's our answer. Let's look at the following question, because now you'll notice that the bases are the same, but the powers are different. So therefore we cannot straight away add them. What we want to do is try and get the smaller power to the same as the bigger power, or vice versa. I'm just going to use the smaller power and get it as the bigger power. Essentially, if I make that times by 10 to the power of 8, effectively I'm moving the decimal point one space to the right, making it bigger. To compensate on the other side, I need to move the decimal point one spot to the left. So it's going to end up as 0.634 times by 10 to the power of 8. Now, we are simply able to add them together as we would have previously, because now, that's an 8, the powers are the same. So now our answer is going to be by 10 to the power of 8. But now the two numbers we need to add together are 0.634 and 1.93. If you need to use a written strategy, please do. Otherwise, hopefully you might be able to do that mentally. So 1.93 add another 0.634 is equal to 2 with a 6 to the 9, 6, 5, 6, 4. So the answer is going to be 2.564 times by 10 to the power of 8. Let's now think what would happen if we had have done it the other way. Let's see if it still works. So let's forget our working out here for the moment. And let's go and think if we had have tried to change this power to a smaller one. So we worked with 6.34 times by 10 to the power of 7, adding 1.93 times by 10 to the power of 8. If we go and therefore make this power here, we're making the number smaller. So in this case, we need to do the opposite as we did before. We need to make this one bigger. So it's going to end up as 19.3. Now that the powers are the same, we can then go and add them together. So we are going to have an answer of, yet again, 10 to the power of 7 this time. And if we add 6.34 and 19.3, 6.34 and 19.3 is equal to 19, and 6 is 25, and 0.3 and 0.34 is 0.64 times 10 to the power of 7. You'll notice with this answer that it is not written properly in scientific notation because the coefficient is not between 1 and 9. So what do we need to do? We need to move the decimal point 1 back, meaning that we need to add 1 more on this, which is going to be equal to our original answer. That is because, remember, in this case, effectively, we are, to get from this number, we're turning it into 2.564, and we're multiplying that by 10 to the power of 1. So 2.564 times 10 to the power of 1 will get us back at our 25.64. So that is now our coefficient, and then we can add those powers together to get us to our answer, which is the same answer of 2.564 times 10 to the power of 8. The key takeouts are, if we have the same power on the base, then we can add the coefficients together straight away. But if they are not the same, as in these cases, then we need to go about making them the same. So if you're making it bigger on one side, you need to make it smaller on the other by the same, or vice versa. If you're making it smaller on one side, you need to make it bigger. Then you can either add or subtract as required. Good luck.